Quantum-styled LED panels. These are some of the latest in LED tech, offering nice boosts in efficiency. They're not bogged down with cooling fans or unneeded light switches. Some kits are DIY, requiring assembly, but what if you just want to buy something and plug it in? Well, today we're looking at the Spider-Farmer SF1000. We'll look at some specs, some PPFD readings, and compare them to some older LED systems. Want to know how to decode those mystical micromole per joule ratings? I'll also tell you what I didn't like about this seller's product claims. So let's dig in. There's no significant assembly required. With the SF1000, we just attach the hanging cables and we're all set. Now for these diodes. Some low-end lights might offer only a single diode color, but Spider-Farmer uses a custom blend optimized for plants. A nice broad range of colors rather than a few isolated bands. Overall, the light looks fairly white, so it's easy on the eyes and it's good for accurately monitoring plant health. I ran this light for 4 hours in a room that was 80 degrees Fahrenheit. The back of the aluminum board reached temperatures from 130 degrees at the corners to 140 in the center under the driver block. So this does heat up, and you should be careful when handling and positioning the light. What really counts though is how much light this thing throws. And this light is bright. Cameras just can't do it justice. My Apogee SQ520 quantum sensor gives much more accurate readings when comparing custom LED spectrums. I'm taking PPFD spot readings along a 4-inch grid inside a reflective wall measuring 28 by 28 inches. Right away, I noticed some strong, consistent numbers at 24 inches. With an average PPFD of 375, running this light at a cycle of 18 hours on and 6 off would produce a DLI of 24.3, and that's actually quite respectable. I'm phasing out this old LED, so I'll take some readings for comparison. They're both pulling about 100 watts at the wall, but this UFO is older tech. It has to divert power to a cooling fan, and in general, the LEDs just aren't as efficient. At all these distances, I see much stronger numbers from the Spider-Farmer LED. Efficacy, a crucial spec when comparing two grow lights. How efficiently does a light convert electricity to plant-usable photons? Are you familiar with lumens per watt? Well, in horticulture, we can compare the micromoles per joule. 1 joule per second is a watt, so this J deals with the electricity used. And this unit, this is the ppf, the amount of par photons being emitted as measured in micromoles. The higher the number, the more photons your light pumps out per watt of power consumed. Higher is better. Even right now, some older LEDs might still be 1.8 or less. Does that mean this 100 watt LED could replace a less efficient 1000 watt model? Well, that's what the seller said in their Amazon listing, and I'm gonna say, absolutely not. That's an overinflated claim, and here's why. To achieve the same PPF output as a 1000 watt model, you need to replace an LED that only yields 0.27 micromoles per joule. Look at these rather dated specs showing some reference numbers from a few years back. Even then, LEDs were anywhere from 0.89 to 1.7 micromoles per joule. So what's a realistic example justifying an upgrade? Let's say that you have an older LED rated at 1.8 micromoles per joule. It's 150 watts. Multiply them for a total output of 270 ppf. This SF1000 draws 100 watts at 2.7, so it too would output 270 ppf. Thus, this newer Spider-Farmer should be able to replace a 150 watt LED, or maybe a little higher, perhaps 250 watts, but not as high as a true 1000 watts. To test this estimation, I dug out a third light. This 200 watt LED from the 2016 era. And surprisingly, the Spider Farmer 100 watt LED had higher numbers than the 200 watt model. It was close, but the Spider Farmer pulled out ahead. So yes, I would say you could replace a 250 watt model if it's from 2016 or older. The problem is, many LED sellers give inaccurate wattage specs. They might call their light 1000 watt, and then they say that it only draws 200 or something much lower. These are false wattage specs. After posting my Amazon review, the seller emailed me. Their product listing was referring to competitors like that, sellers who trick consumers by calling their light 1000 watt even though it isn't. I agree, the Spider Farmer LED could easily replace many of those models. Just look at the actual wattage consumed and ignore those fake wattages. A good seller will list their micromole per joule rating. Without that, it's hard to compare LEDs even when you get true wattage specs. Going further, look for PPFD or light intensity maps. They should show more than just a center reading. Ideally, we would also see values at a few distances. At a minimum, we should see spectral graphs, efficacy ratings, and we absolutely need accurate wattage specs. So, what are my final thoughts about the Spider Farmer SF1000? I think it will be an excellent upgrade that will fit perfectly in my small growing space. It's a great option for lettuce and for nicely sized seedlings over a 3-foot by 3-foot area. It could get you by with some entry-level performance in a 2-foot by 2-foot area. But their listing also shows a 2-panel and even 4-panel version, which would really get the job done for larger, high-end applications. Be sure to watch my other video, which goes into depth on the SF2000. Check the description for a link to their product on Amazon if this seems like a good light for you. Thanks for taking time to watch. I hope this info has helped you out. Please subscribe if you haven't already, and as always, happy gardening.